So we'll talk about this idea again of transformations. So we have like an example here, and I'll just write the original function in. Notice that both of these are sine, so neither of these are cos. So we can try to remember those first 5 important values, but more importantly, we'll write out the original equation. Y is equal to A, and then sine B x plus c, and then finally we add the value d at the very end. So the very first thing we're going to do is we're just going to try to figure out which of these numeric values pertain to which of the letters in the original equation. And you'll see by their position, once you get the hang of it, it'll be pretty straightforward. I'll try to use the same colors. Our a value here is essentially the value of 3. So that's going to have a vertical, okay, stretch to it. And it's going to multiply by 3. So think of it like taking the y value and multiplying it by the number of 3. Okay, and we'll actually show the graphical representation of this after. The first thing we're doing is just getting used to picking out the values. Our b value happens to be the number 2 in this case. So this is actually going to make a horizontal, okay, but it's going to be like a horizontal compression of a factor, okay? And you're going to be actually taking the x value and dividing it by 2. So it's going to happen more frequently. That's what the division happens to look like, okay? The c value is pi over 3, and that has to do with horizontal again, but that's a positive, or sorry, because it's a positive translation, it's a movement to the left by pi over 3, okay? So keep that in mind. Pi over 3 is actually 60 degrees, just in case you're more familiar with the degrees aspect of it. So it's moving everything a phase shift of 60 degrees, or pi over 3 to the left. And then finally, negative 12 is our d value. And that's actually going to have a vertical translation downwards. Okay, so we're going to say downwards because that's vertical. 12 units, or negative 12, we could say. Pardon me. So if we were to show this graphically, I'm going to jump onto Desmos so we can take a look at it. We already have 3x. So you'll notice that y value has been multiplied. So their maximums, what used to be 1 is now the value of 3, and the minimum that used to be negative 1 is now negative 3. So it's really impacted the vertical stretching compression here, or in this case specifically stretch. The next part, I'll rewrite the same one, so we'll do this one at a time. We're going to put in 2x, okay? So we'll hide the old one. You'll notice we still have that stretch, but the phase shift, and we talked about this before, the original blue one takes 2 pi. That's how long it takes for it to actually get over to complete an entire period of the function. Let's just jump so I can draw that. Okay, I'll draw on the page for us. But in this case now what's happened is this has now happened, we've divided by 2, so a period actually happens twice in that same span. So one period is actually only takes the value of pi. And remember, this period before used to be 2 pi, but because we had the value of 2, like we said, we take the x value divided by 2, and now a period is actually the equivalent of pi in this case, okay? So we'll take that one, and we're going to add a little bit more to it. We'll do the horizontal movement. So sine, and don't forget there's an extra bracket here. You need 2, and plus, I think it was pi divided by 3 was our value. There we go. Let's go with the brackets. There we go. Finally got it. Okay. So we'll turn off the green one. What's happened now, actually the green one's not bad to show. I know it's a little confusing. Maybe we'll turn off the original one for a second. Is what's actually happened is we've moved from the purple, or sorry, from the green to the purple. We've moved to the left like we said we would, and we've actually moved it pi over 3 units. So at one point, let's see if I can get an actual value here, make it a little easier to understand. This was pi over 2, and now it's pi over 6. Okay, so that same coordinate is pi over 6. So how did that happen? We can do a little bit of addition math here. We had pi over 2, and we said we had to move it to the left. Okay, so we took it and we subtracted pi over 3 to get some value. Apparently we get pi over 6. Well, we'll have to make sure we have a common denominator here, right? So a common denominator would be the value of 6. So if I multiply this one by 3, I'd get 3 pi over 6. And here we would get, sorry, not multiplication, subtraction. We multiply this by 2, 2 pi over 6. We end up with pi over 6 as our value, and that's exactly what we found the new value to be at. This is at pi over 6. So we did some subtraction or addition. Technically, it's like adding a negative value. We subtracted pi over 3 to get that new value of pi over 6. So we have that shift to the left, okay? And then the very last thing that we had to do to this equation, we'll copy it since I had so much trouble writing it last time, negative 12. And it doesn't even show up on this page. So I'm going to go from the purple one before. I'm going to zoom out a little, and there you go. You'll notice that everything, so we had a high point of 3. If you take 3 and subtract 12, you end up with a y value of negative 9. So all we did was take that original y value. This was at 3. And we did 3, subtract 12. We end up at negative 9. The low point here, I think, is negative 3. So the low point here will be negative 15. So this is actually our final curve of this equation. So a lot has happened. It's been vertically stretched. It's been horizontally compressed. It's been phase shift to the left. And it's been moved down your negative 12 units. So we've done a lot from the original one, which is actually in blue. I'll turn on the blue one here. That's the original one. And we've gone all from the blue one to the black one now.